Hello friends, welcome to Inside Physics. In this session, we are going to see the force between two parallel conductors which are carrying two currents IA and IB. We say that IA and IB may or may not be equal, but A and B are two parallel conductors of very long length and very finite area of cross section. They are separated by a distance d. Okay, and this is the length of the conductor we have considered, where we will calculate the force on this particular length. So, two conductors which are parallel carrying two currents. We know that according to Biot-Savart law, the conductor carrying current will have a magnetic field around it like this. So if the thumb shows the current direction and the curled fingers will be showing the magnetic field, and due to this magnetic field, this conductor will experience a force called BA. Force on B due to the conductor A, that is written as force on conductor B due to the magnetic field generated by the conductor A, that is written as BA. So how to get the magnetic field according to Biot-Savart law? We know that the generation of magnetic field around this conductor, and we actually take the Ampere circular law to finalize the magnetic field because of this conductor. So Ampere circular law, we know that B into length is equal to mu naught I. So L is nothing but length, the perimeter of the loop actually imagined around this conductor. So see, to calculate the magnetic field using Ampere circular law about this conductor, we need to imagine a loop. What is the radius of that loop? That must be length d. So that loop will actually go like this into the board, and here coming out of the board, the loop will be around this conductor. So on that loop, we will calculate the magnetic field using this Ampere circular law formula, where L is the perimeter of the imagined loop around this conductor. Remember, we are calculating the magnetic field due to the current passing through this conductor A. So here we want to get the magnetic field. So mu naught I. So I means it is IA, the current passing through the conductor A. So what is L? See, here L is nothing but the perimeter, as I have told you. This is nothing but 2 pi d, where L is taken as 2 pi d. So 2 pi r is the perimeter of the loop, which is having a radius of d. The d is distance between these two conductors. So what is the force acting on B due to the magnetic field generated by A? This is the magnetic field generated by A. We know that a conductor experiences a force equivalent to BIL. Okay, so the force experienced by this conductor B due to the magnetic field generated by the current passing through the conductor A is given by F BA is equal to, the magnetic field is this one. So magnetic field generated by A, we write it as BA, That means mu naught Ia by 2 pi d. Okay, I means here the current passing through the conductor B. The B I have taken from this part, and I, what is I? IB passing through the conductor B, and L. L is a length, some part of the length we have taken. So FBA can be written as mu naught Ia IB by 2 pi d into L. Similarly, we can calculate, see, magnetic field BA will be going like this as per the curved fingers, like this, and it will go into the board at this particular conductor. So into the board we cannot show as in a three-dimensional way. So in that case I will write BA as like this into the board. Okay, so BA. Similarly, we can calculate the force experienced by this conductor because of the magnetic field generated by the current IB passing through the conductor B. So that can be written as FAB, means the force experienced by conductor A due to the magnetic field generated by conductor B. That in the similar calculation, same as we have done here, we will get the same result. Okay, we will get the same result here. So I will write FAB is equal to mu naught Ia IB by 2 pi d into L. So if you observe these two, which are equal in magnitude but opposite in direction, the force FAB will act in this direction. So there are two forces which are mutually attracting each other between these two conductors because of the magnetic field generated due to the current passing through the conductor. That's why I have written the heading as force between two parallel currents. So by these two we can write FAB is equal to minus FBA. So here Biot-Savart law actually following, and the Lorentz force also. What is Lorentz force? This one. The force acting on a conductor or a moving particle can be represented by Lorentz force. Here the Lorentz force is BIL. So this force and the Biot-Savart law also follows Newton's third law. Newton's third law is applicable in this case because FAB is equal to minus. There are two equal and opposite forces acting between these two conductors A and B. Okay, so here the definition of ampere can be derived from this process phenomenon. How we can define the ampere means, ampere is a current passing through this conductor which is very long and of a very finite cross section, which are both are parallel. So they are separated by a distance 1 meter. Okay, both are separated by a distance 1 meter, and the length what we have taken is also 1 meter. So ampere can be defined as the current passing through the conductor which is having a long length and finite area of cross section separated by a distance of 1 meter. This the force acting on this part 1 meter. The L is also taken here as 1 meter. The force acting on this part of 1 meter length is equivalent to F is equal to 2 into 10 to the power of minus 7 newtons. If this is the force acting between these two conductors on each other, then we can say the current flowing through this conductor is 1 ampere. This is the definition. This is a theoretical definition. When you are coming to the practical definition of ampere, we must neglect the Earth's magnetic field here. There will be an effect of Earth's magnetic field on these two conductors because we have not considered in the Earth's magnetic field. But as a definition, if you want to define the ampere very practically, you need to also consider the Earth's magnetic field. So here see the length. In each case there is a length part, and if you consider the force per unit length, the force per unit length formula can be rewritten as IA IB by 2 pi d. This is the force between two parallel currents, where IA IB is the currents passing through two conductors, D is the distance between the two parallel conductors, mu naught is the permittivity of free space. This is about the parallel currents and the forces acting between them. The next session will take up one more topic.